All right. Hello and welcome everyone to this webinar titled OpendTect Machine Learning Developers Q&A. My name is Adib Jaglan and I work as a senior geoscientist at DGBS Sciences, the company behind OpendTect. Now, the primary objective of this webinar is to help people get up to speed on Python development around OpendTect's machine learning plugin to code their own custom machine learning workflows. So we are going to cover things like using the training data expected in OpendTect in your own IDE and importing the custom trained ML models back into OpendTect so that they can be easily shared and used by non-Python geoscientists and engineers as well. So today we have our CTO Arnaud Huck with us to help us answer these questions. We have already received a few questions in advance, which is what we'll first start with. You are all more than welcome to ask more questions through the chat box, and Arnaud can eventually answer those as well.
I would like to show you this webpage, which is on our website, dgbs.com. Inside the section dedicated to the machine learning plugin. And it is this webpage that we utilize in order to basically gather all the knowledge we want to share with our users on the machine learning plugin and workflows in general. So it shows you well, how to get and install the OpendTect software, how to access the free surveys on which you can train yourself using this plugin, and the Discord community. So the Discord community is an application that you can join, and whose goal is to allow you to basically connect to a number of discussion channels and ask questions outside of a webinar such as this one, in order to get a quick help from, well, either us, from either DGB, or from any other user connected to this community. Of course, you'll also find in as a number of as tutorials and guidelines, all the pre-recorded previous webinars are listed here in order of time, and the link to the main software documentation, so the machine learning user documentation, the documentation for the ODPy Python module we wrote, and we'll soon add also a similar link for DGBPy.
So Arnaud, let me start with the first question. And here it goes. So the first question is, how can I add my own trained model to the OpendTect database?
Thanks, Adib, for this first question. So coming back to the question on how to load and import it, get an already trained model inside OpendTect. Now I'll assume for this that you already have a trained model in the software. These ones are supposed to be quite easy to import. Like basically anything you want to import in OpendTect, you have to navigate and get to the survey import menu to find the option to import pre-trained models. And that will actually start an application where we can actually do the import. Then it's only a matter of navigating through the file. So in that case, I've my stored trained model is next to my Python scripts. It's an HDF5 file because I trained it with the Keras TensorFlow platform. And I'm gonna basically open that file. Now, in order to be usable in OpendTect, we need to get a number of information from the model. Information will be like the geometry type. Are we looking at a 3D model or a 2D model? What is the input shape? What are the input dimensions? What is the output shape? How many input attributes do we have? How many output attributes do we have? So if I trained, for instance, an image-to-image model, will have one input attribute, one output attribute. If I did run a supervised segmentation, for instance, we'll have one or several input attributes and we'll have as many output attributes as labels to be predicted. Now we tried during this import, and that's why it takes time, because we actually run a number of Python commands in the workflow. We try to retrieve as much information as possible from the model. That depends, the amount of information we can recover from the trained model depends heavily on the platform. For Keras TensorFlow, we know that these models have a quite extensive header, which allows us to pull in information like the input shape, output shape, how many input attributes, how many output attributes. What they still do not contain is they don't contain a label. So the trained model doesn't know if it was trained on seismic data or on acoustic impedance data or on anything. So if I want to label the type of data set that was input, I have to do this manually. It's not included in the file. What is included in the file is that it still did get that this is a model which is classifying data. So it is running a segmentation, and it did get that it's segmenting into 9 labels. But again, the actual label names are not stored in a standard TensorFlow model. So I will need to provide label names, like this is a salt body, this is a limestone, and so on. So the essentially the labels are never included in the trained model information, and that is typically information that will always need to be provided by whoever is importing the data. Another piece of information which is almost always lacking is the information on the scale on the input data. The scale is not so important if you stay within the project on which the model was trained, but if you if you have trained the model on a data set, let's say, I don't know, from the North Sea, and you want to apply it to a different data set in the North Sea, but a different seismic survey, it will likely have a different scale. So as such, ideally, it should be better to provide information on the scale of the data on which the model was trained. Now, if you still have access to the data set, I would just recommend you to fill in this information. That information can quite easily be pulled from the seismic data by computing the histogram of the seismic and providing that information. Okay, so with this histogram information, we can get quite quickly access to the standard deviation of a data set, and that would normally be sufficient to provide information. Well, the average is not strictly 0, but because it's seismic, I still decided to set it to 0. And basically, importing an already trained model corresponds to filling in such form in the import window. Now that can still be a bit cumbersome, and it's not yet sufficient to get a reliable import working in all cases, which is why we're still currently expanding the scope of this import facility. I'll share you now a small number of slides showing you how we are currently extending this tool. in order to get a slightly more robust sharing of these pre-trained models. So first of all, we are adding a number of items to the machine learning toolbar. So in the Machine Learning Control Center itself, you'll get a direct access to having the possibility to change survey, open the dataset manager, seismic manager, the point set manager, the pre-trained models manager will be directly available to inside the Machine Learning Control Center. And you'll have a dedicated toolbar, which is similar to what you see in OpendTect as well, to get the Python settings to launch your IDE or get a command prompt to execute Python commands. That's for the Machine Learning Control Center itself. So in the current control center, you'll find the pre-trained models directly underneath the items for each and every workflow. So this is where you'll find the list of pre-trained models. Now, because we ideally expect that you'll have eventually a quite large list of pre-trained models, we couldn't expand that list indefinitely. So that's why we decided to make a dedicated section in the Machine Learning Control Center for the pre-trained models, which would still be grouped by workflow. Now, these models can already be directly available, so installed with the software or somewhere on a local network location, but there will also be models to be downloaded. So that's why the items which have not been installed yet, which are not directly available to the software, will be marked with a download status button. And that means that these models are available somewhere on the network, either the local network or on the web, and they can be downloaded for usage in OpendTect. We also added a button to get a more decent amount of information about the pre-trained models. And when it comes to downloading these models, we want to support just pulling these models out of a network location you have on your local network or from cloud storage using either a public download link, like an S3 download link, or using a more private repository like a bucket on Amazon or in an Azure cloud storage. So the pre-trained models information will show part of the information which is to be filled in the current import tool, like the input label name, the output seismic name, shape, model name, and so on. But it also contains a section holding information that the user who actually trained the model can utilize. So basically, what we want to be able to do here is that we want to be able for the interpreter who has trained a model to actually write a summary of how this model was trained, on which data it was based, for which purpose it can be applied in order to run predictions on other projects. And this amount of information, which is to be filled by the user who has trained a model, is something that we then carry on across all the import steps, so that eventually whoever wants to use that model knows that it can be applied in a given setting. The models, when they are downloaded, will be, well, we have two default download locations. These are the ones which are enabled through the software installation. And what you can do as a user, you can add a location which is somewhere on your local disk or on a network disk where the downloaded models have to be transferred and stored. And this is ideally a centralized location. It's more ideal to use a network location for this because that allows sharing these models across the team. So if you have user A which downloads a model to a shared location, then his colleague from the same team doesn't have to download the same model again. It can just read it from that network location. Okay. So eventually we'll expand the scope of the import pre-trained model window and user interface in such a way that all the information you see here when a model is ready to be downloaded can be added. Okay.
Yeah, perfect. Thanks, Arnaud. I have a counter question here. Will this new pre-trained models facility be available in the next release, next public release?
So the import there are a number of things which are directly available. These 3 pre-trained models are directly available, and the last 2 will be already downloaded from the internet. It works for now slightly differently in such a way that instead of downloading these files to a centralized network location, they go into your current project, but as such, they are already directly usable. But for the all the items that you saw, we'll have to I cannot guarantee that it will come in the next version 665 because that one is almost ready to be shipped, but it will certainly come in a release soon thereafter.
Right, perfect. Thank you. Yeah, so that was about the model trained model import in OpenTect. The second question is about reading a training example training file created in OpenTect outside OpenTect in our own ID, for example, Jupyter Notebook or Spider.
The example files. Yes.
Yeah, example files.
Now, for one given workflow, if I go to this workflow, first of all, you need to know where that file actually resides. So if you know you have created an example file, let's say for this workflow, seismic image segmentation. All right. So in the extract data tab, you have always next to on the same line as where you can provide the example data. So it's this line of the extract tab. It's the first line in the train tab. You have this tiny manager icon. So this manager icon allows you to directly open the corresponding data manager, and like all data managers in OpenTect, this one will show you the location on disk of that data set. So with the full file path to it, so path and network location. Now, if you want to get the data inside that file loaded in Python, so I've actually launched Spider, and you can launch it from this button directly in the control center or from the equivalent button in OpenTect. If you're using Jupyter or any other IDE, it's exactly the same, just the icon. You only have the icon which changes. And well, you'll have to use one core module of the DGBPy module. That core module is the mlio. mlio simply stands for machine learning input output. Everything you want to read or write, which is about the machine learning plugin, is concentrated into this package. So if we want to get quickly some information on this, so first of all, I will need to define my file name, and that is best done by just copying the location from the merger. And you can see that the merger already shows some information on what data was extracted. So I'm going to simply copy paste this path. I may not take this one because it's a quite large one. I'll take another slightly smaller data set for this demo. On Windows, you have to be a bit careful with the file path because we have to duplicate these symbols, otherwise they are not recognized correctly. And the first thing we can that we want to do is simply to know what we are talking about. So if I just ask and get this get info function and I run it, it's gonna give me such a dictionary. Okay, so this I've just opened the output dictionary, which is returned by this function, and well, it shows me a number of things. It shows me that it's data which was extracted for the purpose of running a classification. It shows me that it's the class numbers to be predicted are simply 1, 2, 3, 4, 5. It's giving me the input shape, so it's looking, apparently I'm looking at a 2D image, 128 by 256 pixels large, and well, there's some information on the data set on which it was extracted, what kind of learn type, what the output shape is going to be. So the output shape is same as the input shape. So we are looking at an image-to-image workflow. Okay, and of course, still the full path to the data. It also gives me some information on how much bytes this file content would be taking if I would preload everything in memory. Okay, so that's really just to get to pull out the header, and that's the header which is equivalent to what we see here in the manager. If we want to actually get the data, we can get the data again from mlio. We can ask to get the training data from our file. And again, I'm going to run that, and it's going to return me this data member. Again, it's a dictionary, and this dictionary basically contains the info section I extracted before. So that means that if I also want the data, I can actually omit this part and get directly to the data, to the get training data function. And then we have these two functions, these two members, xtrain and ytrain. That means that if I want my xtrain array, all I have to write is to extract the xtrain item from that dictionary. Using the right keys. Okay, so if I do this extraction, I'll just do it now and clean that. Okay, so now I get the two arrays xtrain, ytrain, and I can see that we have 70 images for one attribute with an image size 128 by 256 samples. For the X data, so that's the input for the prediction, and the Y data, that is the output of the prediction. Okay, and that is as such the raw content of the file dumped in memory and directly usable in order to start some training. Now, if you want to do some training, actually, you probably don't want all of the X-train data, all of the Y-train data. You probably want to have it split and to have it split between an actual training data set and some validation data. If you want to do this, because it becomes a slightly more complicated actual training workflow, you have to use another module which is in GGBPy, which is called mlapply. And mlapply saves, well, does something quite similar, not exactly. So what we can do mlapply, and we'll call a very similar function, which is called get scaled training data. And instead of getting the raw training data as such directly from the file, we'll call that function instead. And it will do slightly more work in the background. If I look now at the train data dictionary, well, as such, the only difference between these two so far will be that we'll make use of the scale information in order to normalize each input attribute to an RMS scale of 1. But it's still not divided into an actual training data and test data. So to have this done, we'll have to split the data, and so far the only split method we have implemented is a random splitting of these two arrays based on the percentage, 80% for training, 20% for validation. So I'm going to run it again. And now the dictionary contains not two arrays, but 4 arrays. One X-train array for training, 80% of the data, so 56 images out of 70, one for validation, and the same two, which are the target of the training to be provided when we actually train the model with the fit function. Okay, so as such, these two functions, mlio get training data, mlapply get scale training data. That's basically the only thing you have to do in order to read any example file created in OpenDetect prior to training if you want to do the training in Python. There's simply nothing else that needs to be done. And for the splitting, because it's random, that means that every time you call that function, you get a different mixture of training and validation data.
Great. So Arnaud, just to confirm, these two functions also work on log.
So these are the same functions for any platform, for any workflow. They're completely to be used in the same way.
Perfect. Yeah, right. Maybe we can also, in the meantime, take a question from one of the attendees, Martin Hugo. Can you see his question now? It's about SynthRock development, and yeah, it's linked with ML plugin, I believe.
Yes. So in the machine learning plugins, you see that indeed you have a number of predefined workflows to get your data extracted from the OpenDetect database. Most of these are extracting full-blown seismic datasets, 3D or 2D seismic datasets, using point sets if you do a seismic image segmentation, a seismic bodies workflow, or using just the seismic datasets or the well logs, the stored well logs from your database. But indeed, there is yet no option to pull data from SynthRock. This is actually an item which will eventually be added to the option seismic and wells, because under seismic we do not need only the actual stored seismic survey, but we also mean the synthetic seismic traces that you may have for well data. So we are at the moment in developing a bridge which allows the extraction of the data from SynthRock simulations to the same kind of HDF5 containers. So the development of this data extraction link is still in progress, but it's something which will be made available probably by the end of the year. We'll have it sooner available internally, but we are currently working on it. And it's definitely a must-have in order to do any robust kind of rock property prediction. Because you have to keep in mind that in order to get a reliable training done, you need to provide a very large number of input data. If I was to train on this data, which has only 70 images, but you can be pretty sure that the training would never succeed or give any reliable model. And the main issue you have with well data in these workflows is that except if you're very lucky and you have access to a huge database, then maybe you'll have access to 100, 200, maybe 300 wells maximum, good quality wells. But that is still a quite small amount of data to train on. So that is why sooner or later, if you want to work with well data, you have to simulate more well data from the existing logs, which is what SynthRock is about. And once you have simulated, you have added modeled wells, then you want to be able to extract this data, get it into an example file, so it can be used for machine learning training. But it's a development in progress.
Right. On that note, he is also asking some question. Also, can pseudo wells be exported as .las files?
As LAS?
As LAS.
LAS.
LAS, yeah, LAS.
Yes. No, we don't plan to export them directly as LAS files. One reason for it is that in SynthRock, you are typically simulating hundreds, if not thousands, of pseudo wells. And that means that, well, you would have a tool which would create thousands of LAS files, which then still have to be imported in a software before they can be utilized. So our SynthRock link will directly create example data in the same format as what you can already extract for logs. And that is a format which is directly going to be usable in Python for training purposes. That's one part of the story. Another part is that in the Python module ODPy that we are writing, in the ODPy module, you have a package called Wellman, whose purpose is to pull well data from the OpendTect database when you are in Python. So if you have all your wells loaded, and we'll probably have a similar one to access the SynthRock wells at some point in time, well, you want to get quickly the possibility to list all the wells available in the survey, and more importantly, to read their logs. So if you have stored wells in the OpendTect project and you're in Python, then this module, Wellman get log, will allow you to get your log data in Python much more easily than trying to read them through LAS files. And as soon as we'll be done with the SynthRock data export, you'll also get a similar API for reading the logs of simulated wells from SynthRock. Okay, and that really eliminates the need workflow of creating any LAS file, well, thousands of LAS files for this purpose.
Okay, yeah, that's clear now. You were showing the functions in DGB mlio to import training files created in OpendTect. I understand one can also import a trained model the same way.
Yes, a trained model can be imported in the very same way, and the starting point would again be also be the same. So let me go back to a seismic bodies workflow where I have some trained models. So if I'm looking here at the API for the trained models, we have the manager, and this manager shows me a list of already trained models in that current project. So these are models which reside in the current project. Eventually, if you recall what I was talking about for the pre-trained models, which would be available on the network location, we also want these ones to show up in this list eventually. So you won't have to make a distinction between the models in the current project and the shared models that you would have on a network location. Now, if I take one of these models, again, this window shows me the data on which it was trained. So we get an overview of all the labels for this segmentation on the name of the input seismic data on which it was trained, and the location of that trained model and file name. If I now take this file name, I'm gonna just, so that will be my model file name. It's in the same survey, same folder, actually. So the same folder contains both the example data and the trained models in a project. So in our case, we'll use the function get, sorry. We'll use the function get model of file name, which is about the same. The only slight difference is that it returns a tuple, because we also may want to get the header information that we have next to the model. So let me run this one. Just hope that it works. I think it's done. So we get these two objects. So the info section is again the same, and the model here that we receive is directly, in that case, because the model was trained in TensorFlow, it is directly a TensorFlow model instance, actually a Keras TensorFlow instance. No. Anyway, and so that model is directly usable for running a prediction. If you have some data on which you want to do the prediction, you can directly run the prediction in this way for any model. Actually, in that respect, both TensorFlow and Scikit-learn use the same predict function for this purpose. So the predict function is actually, at least across these two workflows, the same. And again, there's absolutely nothing else to be done than calling this one function get model. Okay. If we are looking at a well model, so I'm going to take another well model So going back to the log prediction workflow, again, I'm going to the train tab and the manager. So this is my well model. I actually see that it's an XGB regressor from the Scikit-learn platform. So that's what you already see in the model manager. You see on which logs, what is the target log, on which wells it was trained on, with which input logs, and that is the output file. And it is this file we need to provide here, just in the same way. And again, to read that information, we'll have to call that similar function in such a way. And that's all we have to do. The output of this model 2 option is then directly, it's not a fancy object we have created. You directly get a model from the target platform. In that case, it is an Scikit-learn XGB regressor. Okay, so we try to make the pooling of the data for for the example data, just as for the trained data, as easy as possible. It's down to calling a single function for all platforms, for all workflows. You only have to call a single function from mlio, sometimes from the DGBPy mlapply module, and there's nothing else to be done.
Perfect. So it's good to know that the syntax is consistent and platform independent in both cases. Great. Okay, let's quickly move on to the next question. Also, a little bit of time a bit. Yeah. So the next question is, can I use data augmentation specifically in Keras TensorFlow model training?
Yes. So data augmentation means that, for instance, if we have a limited number of images in our input data, so typically in these two arrays, that we want to virtually make more data out of these two NumPy arrays while it is being trained. That is a possibility which is partly supported inside TensorFlow, but it does require to really do some implementation inside inside our modules. So, for instance, just gonna browse. Just gonna open. So this is an operation which is never gonna be really accessible cross-platform. In order to enable that, so first of all, we still have a rather experimental support of this option, and because it's still experimental, we don't want to enforce it to be done on each and every training. We have added an environment variable called Keras with augmentation that you can set in order to enable the data augmentation if you are training in OpendTect a Keras model instance. What it will do, the implementation we have so far is quite simple. If you have a 2D image like this one, it will do a left-right flip of each image. So that means that we'll virtually train on twice the amount of input data. And if you have 3D images, then we'll apply vertical rotations by 90, 180, and 270 degrees, virtually creating 4 images out of each input image. So that means that if you have 200 3D images, you actually train on 800 images. Okay, so you have to keep in mind that is going to cost a bit in terms of resources, both memory and processing resources, but it's a possible way to add data if you don't have enough. I would want to say that another way to get more data that should not be forgotten is to try to also extract as much data as you can. That of course depends on the workflow you're in. But if you are in a certain workflow, like here, this is the data extraction for the image-to-image workflow. You can see that we give you a small overview depending on your extraction parameters of how many images you would be extracting. So in that setting, for a given inline crossline range, I would be extracting about 500 images, which is a good start. But maybe I would like to get more images extracted from that same data set. Now, you cannot expand your seismic survey, but what you can do to get more data extracted, and in such a way, it's also part of augmenting the data, you can increase the overlap between the extracted images. So that means that you do not extract contiguous images, but you extract them with a large amount of overlap in the 3 direction. And then by playing with these overlap options, you can efficiently increase quite easily the number of images to be extracted. Okay. So this is, I would say, something to keep in mind, that depending on the workflow you're in, it is possible directly at the data extraction phase to get more data extracted. And if you still do not think that it is sufficient, then you can switch on the environment variable Keras with augmentation and have more data created while it is being trained. Okay, if you are in a workflow, which is pixel based, like the seismic bodies prediction, then the workaround would be simply to pick more, to make more larger point sets, to pick more examples on the data, which is nowadays quite easily because we've added in OpenTect this paintbrush tool, which is placing dozens of seeds as you are dragging over an area. So you don't have anymore to pick every single point when you provide when you prepare a point set for labeling purposes.
Very well, thanks, Arnaud. And we are a bit short on time, so probably we can take one more coding-based question, and then we can move on to generic FAQs that most people have. So the last sort of academic question would be, how can I write my own new TensorFlow Keras model architecture or code inside OpenTect environment?
Yes.
Make it available in the ML plugin UI.
So to answer this question, I'll start by assuming that you already have a given model architecture. So that means that I assume that you already have a code like this, which is written, in my case, purely in Keras code, which defines a model architecture and which returns a compiled model. Okay, so that is code I assume you would already have available. And the question is more than how to make that model architecture available in such a way that it can be selected in the OpenTect user interface when you do the training inside the machine learning plugin. Now, this is summarized in a document from our FAQ. So if you go to the OpenTect, that's the DGB user documentation for the machine learning plugin. And in the introduction and terminology at the end, like we have on a number of other web pages I showed you, we've listed a number of resources, including that one, how to develop your own models, which is a dedicated documentation. So if you open that one, you get a full documentation on how to do this specific workflow. Okay, and well, as a nutshell, from what you see on screen, we already have this. So we already have code which creates a model, which is setting up the architecture, compiling it, returning it. So this is the part which we already have. To make it available in OpendTect, you have to use what is called the user model class. So the user model class you'll find again in DGBPy. So far, it's on something we have only made available in the Keras platform, but eventually we would like to have it also in a platform independent way. Because it's only available for the Keras platform for now, this user model class resides in the Keras classes script. So this is the one thing to import, and you'll find the description of this class at the end of it. Now, if we just look at the documentation, actually the only thing we have to do is to copy paste that snippet in our existing code. Okay, so the function which I called now make model, actually do it slightly differently to preserve that. So we defined our own class, my model, which is of type user model. Of course, one thing to keep in mind is that we'll have to import a number of items from DGBPy Keras classes. So these imports were Keras specific. This is just the addition from DGBPy. So we define a number of data types. And now all we have to do is to call our function, which is to return the unit for a certain input shape. That is really the strict minimum. Okay. Now you have to be very careful with what you have to give here. So the UI name is the actual labels which will appear in the OpendTect user interface as you try to train a model. So if I go here to training, apply, just gonna get something on screen. So this is the name which will appear in the user interface. This is just a smaller description for your purpose. And we have to specify, well, which kind of prediction type we are looking at. Are we looking at something which is running a supervised classification, or are we looking at something which is doing image-to-image prediction? Yes, these are enums, Python enums that you can look into in this Keras DGBPy Keras classes option. Okay, so you have to say, are we looking at doing a classification or a regression? And we have reserved the word segmentation for the unsupervised workflows. So classification is always supervised. You do provide the labels to train on. Segmentation will be for the unsupervised workflows. Output type is a pixel if you are training on a point set, is image if you do image-to-image prediction. So output shape is same as input shape. And you have to specify what kind of dimension your model supports. Does it support any dimension, 1D, 2D, and 3D? Or is it only a 3D model architecture? Maybe it's only a 2D model architecture. So these are items that we have to specify. In that case, this model architecture supports only 3D, is only about 3D convolutional layers. So I need to set that to 3D. Okay, convolution ends with a size of an output size of 1, which is compatible with this pixel shape. Okay, that's in a nutshell how to do it. So there's really not much to do if you want to make your own model architecture directly available in OpendTect. And all of it is really summarized in this example.
All right, very well. Thank you. Probably we can move on to some generic questions now.
Yeah, sorry. One thing I forgot to mention, which is very important, in order to have this model recognized by OpendTect, we basically we agreed that we'll have to give it a specific file name. So the file name containing the model to be pulled by OpendTect always needs to start with this ml model underscore. Okay, because why is that? Because in order to have OpendTect find your model, that means that OpendTect needs to be aware of this file location, of where the scripts are located, and it needs to be aware of which file name in that folder is likely to contain such a script. So the first step is to ensure file name starts with ml model underscore, and the second step, which is in the Python settings, is to provide the full path to this location. So that if I open the Python settings, that's this custom module path, which can be one or more script, and only by providing then the location of that folder and a given file name, that will make it so that OpendTect will find the script.
Perfect. Perfect. Yeah, that's indeed important to know. All right. Yeah, so moving back to some generic FAQs. What's the status of Pytorch about?
So we have been working indeed on adding a third platform to our capabilities, to our machine learning capabilities. So that is the Pytorch platform, which complements TensorFlow and Scikit-learn. As such, most of the implementation is done, and it is going to be currently merged into the production release, tested with the goal to release it before the end of the year. So most of it is was developed already, and we are going to incorporate that in the release, do some decent testing, and make it available to you as soon as possible.
Right. And what if someone has questions about working with the ML plugins, comments, improvements? What are the resources that can be referred to? Could you please elaborate on that?
So next to basically all the resources which are available on this on these platforms, the main discussion channels we would like to promote is the Discord community. So ideally, anyone who wants to get support, share knowledge on the machine learning workflows, has questions, would like to invite you to join that Discord community, and simply to get in contact with the not only DGB but the entire community to get support on these topics.
And what would be the easiest way to get invited on Discord?
Yes, so the easiest way is really to click on this link, join the community. That will have you download the application, the desktop application, if it's not done already. And once you have done this, you can create a new account with username and password, and then connect to the community, to the app. So it's a dedicated application which runs on the desktop, and you can also run it in the browser. You don't necessarily have to use the dedicated application.
That's cool. That's cool indeed.
This is really the main way to join it.
Yeah, very good. So if someone has an idea for a webinar that shows how their company is using the machine learning environment as a success story, for example, or if they have a model that they want to make publicly available, how can they coordinate with you to make that happen?
So you can always send us an email at info@dgbes.com to get in touch with us privately, or if you want to get in touch publicly, again, you can contact us on Discord on all these topics. We are more than willing to organize a webinar if there is something that you think is worth sharing with the machine learning community. So we can host a webinar such as this one for you on a scheduled date. If it's more about sharing data, sharing a model, there are various ways to do it. If you have a pre-trained model, like these ones that you think is publicly worth sharing, or maybe you know about a public model which is directly available on the web, but it's on a web page, difficult to find, then we can make it available through our user interface quite easily. We just need to know where it is located, so we can arrange the data download. If you want to get more help on getting set up to share and distribute your models within your organization in a more private manner, so between offices, but still only inside the organization, then we can help you to get set up with the new way we are setting up the sharing of the pre-trained models. So again, contact us by email at info@dgbes.com or on Discord, and we'll reply to you.
All right, yeah, thanks a lot, Arnaud, for this. I don't think we have any more questions at our end. So attendees, please feel free to ask any questions via the questions chat box, or if you want to speak up, please raise your hand. If anyone is interested.
Yeah. One question I would actually have to you is, we would like to know the areas where you're most struggling with, so we can really focus our development efforts on it. The machine learning plugin has, then, as you can see, various subcomponents. You have the data extraction for machine learning purposes. You have more general data access questions, how we can read logs which are in the OpendTect database, or logs in SynthRock from inside Python. Do you need more help into setting up model architectures or reading trained models? Let us know what tools you are missing, which we don't have yet available in the machine learning plugin, because we would really want to put a focus on the tools you are currently missing. So let us know exactly in which part of the workflow we have to make the largest focus.
Yeah, thanks, Arnaud. That's indeed a valid point. Maybe you could just show up momentarily the Discord UI and the various channels we have in there for anyone who is not aware of this.
Okay, so this is This is the Discord community. You see all the a list of the connected users here, and you have again a knowledge base. That's where you can find the webinar examples, the videos, the links to the various documentations, workflows, datasets, and you have dedicated channels. Questions on how to use the ODPy module, questions on how to use the DGBPy module, how do I get the well data extracted from Python, seismic data. So really per topic discussions. And all the upcoming webinars are always going to be announced on this dedicated channel for the upcoming webinars.
Yeah, excellent, excellent. So if no one else has anything to comment or questions, we can call it a day. Thanks to everyone for your attendance, and thanks Arnaud for quite an informative session on machine learning development across the OpendTect platform. Thank you, and have a good day.
Everyone. Goodbye.